Let's talk about metric system conversions. You will have to do a few metric system conversions. Nothing too complicated, but we are going to be using the International Standard Base Units. So for mass, it's a kilogram, length is the meter, time is a second, temperature is Kelvin, the amount of substance is the mole, and the electric current would be amperes. That'll be more towards the end of the year that we talk about that. But there's all their abbreviations there. These are called SI units. It comes from the French term, which is there. I'm not going to attempt to say it, which means the International System of Units, so SI units. And these are the different base units that we will be using. There are some conversion factors that will be given to you on your data sheet, but here is a list of all the metric prefixes and kind of what they mean, but we're really not going to use some of the really large ones. So looking at this chart, you can see that the base unit, that means there's no prefix. So this would be like meters, okay? And then if you multiply it by 1,000, then you would have kilometers. We're really not going to use the other ones in between the hecto and the deca. If you have a thousandth of a meter, then that means you have a millimeter right there. And then these other ones we do see in chemistry because we're working with really small atoms. So we have micro and nano, both mean million and billionth. And when we get to pico, which has a little p there, this is the size of the subatomic particles of an atom, the proton, the neutron. Your electron is really tiny, more tiny than even the picometers. Temperature, this is the average kinetic energy or heat in an object. Heat always flows spontaneously from hot to cold, and we will use the Kelvin scale. 1 Kelvin is the same size as 1 degree Celsius. Our thermometers in the classroom are Celsius thermometers, so we just have to do this quick little conversion. You can tack on the 0.15, but you don't really need to. So when you go to do any calculation, always remember that the Kelvin temperature is larger than the degrees Celsius. I remember King Kelvin, so it will always be larger. So if I had, say, right here, 25 degrees Celsius, how much would that be in Kelvin? Then all I have to do is do the 25 degrees plus the 273, and I'm going to get 298 Kelvin. Notice it's not degrees Kelvin, it's just Kelvin. So degrees Celsius, Kelvin. The Fahrenheit scale, which we are familiar with living in America, it is set up as 0 degrees Fahrenheit. That is the temperature of salted ice water. That's kind of random. And 100 degrees Fahrenheit, that is the temperature of our human body, so approximate. And then they just took and they separated into 100 lines in between the 0 and the 100. The Celsius scale, it is based on water. So the freezing point of water is 0 degrees Celsius, boiling point of water is 100 degrees Celsius. And then get to Kelvin, we just do math. So we just take the temperature in degrees Celsius and we convert it to Kelvin. For pressure, you need to memorize that at standard pressure or pressure at sea level, the pressure would be 1 atmosphere. And here's the conversions right here. This will be on your data sheet. So you don't need to memorize it. I would, however, memorize it just so you could be fast. So kilopascals we're going to use in the lab, but there's not going to be any questions on your AP tests that use kilopascals. They will always be in torr or millimeters of mercury. That's what Hg is mercury. And those are all equal to 1 atmosphere. And I have seen them do conversions in pressure, so this should be something that you know how to do. So what you learn how to do with conversions and pressure today, that's as hard as it's going to be on the AP test. Volume is a derived unit and it comes from length. So the SI unit for length is the meter. So if you take length with height if it's all a meter. So it'd be 1 meter by 1 meter by 1 meter, maybe about the size of a dishwasher. That would be your standard volume, this cubic meters right here. Here's some conversions that you might see. So 1 milliliter is equal to 1 cubic centimeter. So you might see this represented as cubic centimeters. This conversion is kind of falling out of favor or popularity. you are mostly going to see it as 1 liter, but 1 liter is equal to 1 cubic decimeter. But you will see this first one, but probably not the second one. But there it is anyway. Density is also a derived unit, and a derived unit is a calculated unit. And usually for liquids, you get milliliters, and for solids, you get cubic centimeters. And it's figured out the same way, mass over volume. And so a lot of people memorize this by this broken heart. There's my M, there's my V. And I remember mountains over valleys. So that's another way to remember the density formula. So let's do a few conversions here together. If you'd like to try them on your own and then check, you're welcome to do that, or you can just follow along here. So we have 350 Kelvin. So remember, Kelvin's always bigger. So I know that I need to subtract 273. And when I do that, I'm going to get 77 degrees Celsius. Let's do this next one. So I have 300 atmospheres. So I know that 1 atmosphere is equal to 760 torr, and that's my conversion factor. So start with the number that you're trying to convert, and I like to use these little boxes. And so atmospheres is at the top. To cancel out atmospheres, I want atmospheres at the bottom. And these two values have to be the same. So the same size or quantity. They have to be equal to each other. And I know that 1 atmosphere is equal to 760 torr. So this is my conversion factor. So all I'm doing to that 300 atmosphere is multiplying it by 1, essentially, because my conversion factor is stacked on top. So figure out what's equal to what, and then 1 will go on to the top and 1 will go on the bottom. And remember, to cancel out, you go diagonally. So atmosphere cancels, and I'm left with torr, and I get 22,800 torr. So that's a lot of pressure. And let's do the last one. So we have a lot going on here. If you have 2 units, make sure that you write them in the appropriate place. So I have 5 milligrams per cubic centimeter. That per means divided by. So that means it goes down below. So this is very important. Now, I usually don't put a number in front, but if it bothers you, you can put a 1, okay? So 5 over 1 is 5. So this is milligrams per cubic centimeter. And to convert, it doesn't matter if I start with the milligrams or if I start with the cubic centimeters. But let's look and see what we need to do. We need to go from cubic centimeters, so 1 cubic centimeter I know is 1 milliliter. And I know that 1,000 milliliters is 1 liter. Okay. And then let's look at our grams. So I know that 1,000 milligrams is equal to 1 kilogram. So I know that 1,000 milligrams is equal to 1 gram. And I know that 1,000 grams is equal to 1 kilogram. So those are all the units I'm going to be using. And I think I'm going to give myself a little bit more room here. So this is just kind of a challenge problem. I doubt that there'd be anything like this on the AP test. But let's get this lined up. This is how you do these conversions. And so I want to, let's start with our milligrams first. So I know that milligrams goes down here. So 1,000 milligrams is equal to 1 gram. And 1,000 grams is equal to 1 kilogram. So again, they have to cancel diagonally. Now, once I have my kilograms, then I just have to do my liters. So I have cubic centimeters down here at the bottom, and I think I'm just going to cross that out and put milliliters because it's the same thing, okay? So I have 1 milliliter, and I know that 1,000 milliliters is equal to 1 liter, okay? All right, so now I'm ready to do my math. And I forgot to show you how to do math up here, but basically when you go across, you multiply, and when you go down, you divide. So 300 times 760, that's how I got the 22,800. And let's look down here. So I'm going to have 5 times 1. You kind of do this zigzag pattern. 5 times 1, so multiply here. Then I go down below and I divide. Divide by 1,000 times 1 divided by 1,000 times 1,000. And so when I figure all that out, I get 0.005 kilograms per liter as my answer. Okay. All right, so kind of a more complex problem, but I just wanted to see how you can convert your units. Remember, when you are converting, the ones that get stacked on top of each other, they need to be equal to each other. So we don't want to change the quantity of that 5 milligrams per cubic centimeter. We want to keep it the same quantity. We're just changing the units. All right, let's try these. Again, you can stop the tape and see if you can do it by yourself or just follow along with me. So I have atmospheres to millimeters of mercury. What do I know? I know that 1 atmosphere, and again, you can get this from your data sheet. You don't need to memorize it, but you would save time if you did memorize it. So I'm going to start with my number, so 5 ATM. And then to cancel this out, I want to make sure I have atmospheres at the bottom, and I'm going to change it to millimeters of mercury. I know that 1 atmosphere equals 760 millimeters of mercury. So then to do my math, I just multiply these and then divide by 1, kind of like what we did before. And on this one, we get our answer as 3,800, and atmospheres cancels, so I get millimeters of mercury. And let's do the next one. So the next one we have milliliters and liters, and I know that for every 1 liter, there is 1,000 milliliter, because that's what milli means. It means 1,000. So line this up, 100 milliliters, and then we want to cancel milliliters. Oh, it looks like I goofed there. That's milliliters. And so I have 1,000 milliliters and 1 liter. And so remember to do the math. As you go across, you multiply. So 5 times 1, or 500 times 1 is 500, and then divide it by 1,000, and I'm going to get 0.5 liters. And one more, this one is temperature. So I know that Kelvin is bigger, so this time I'm going to add 273, and so I'm going to get 293.